Imagine a world with robots as small as insects. These tiny robots, often no larger than a coin, are designed to perform tasks that are impossible for larger machines. They can slip into the smallest crevices, navigate through dense foliage, and even fly through the air with the grace of a dragonfly. These tiny machines could fly, crawl, and hop into places too dangerous or difficult for humans to reach. Imagine a swarm of these robots entering a collapsed building to search for survivors or exploring the depths of a dense forest to monitor wildlife without disturbing the natural habitat. It sounds like science fiction, right? But at the Massachusetts Institute of Technology, scientists are turning this dream into reality. Their research is pushing the boundaries of what we thought was possible, creating robots that are not only small but also incredibly efficient and versatile. These aren't the giant robots you see in movies. Instead of towering over buildings, these robots are designed to blend into their surroundings, often going unnoticed as they perform their tasks. These are miniature marvels, designed to mimic the incredible abilities of insects. Their wings can flap at high speeds, allowing them to hover in place or dart through the air with precision. Why insects? Because these tiny creatures are masters of their domain, able to navigate complex environments with amazing agility. They can climb walls, squeeze through tight spaces, and fly with remarkable control. By studying insects, MIT researchers are unlocking the secrets of their movement and applying those principles to build robots that can fly, crawl, and even swim. This biomimicry approach allows them to create machines that are not only efficient, but also highly adaptable to various environments. These tiny robots have the potential to revolutionize how we explore our world. From monitoring the environment to assisting in search and rescue missions, they could be used to track pollution levels in rivers, survey disaster-stricken areas, or even pollinate crops in areas where natural pollinators are in decline. The possibilities are endless, and the future is bright for these tiny robotic pioneers. At MIT, researchers are driven by curiosity and a desire to solve real-world problems. Miniature robotics is a perfect example of this. By building robots on such a small scale, scientists can study the world from a whole new perspective. Think of it like this. Imagine being able to shrink down to the size of an ant. You could explore the world beneath our feet, navigate dense forests, and even fly through the air with ease. That's the kind of access these tiny robots could provide. But it's not just about exploration. These robots could also perform tasks that are too dangerous or difficult for humans, like inspecting hazardous materials, monitoring delicate ecosystems, or searching for survivors in collapsed buildings. The possibilities are truly endless. One of the most promising applications for robotic insects is environmental monitoring. These tiny robots could act as our eyes and ears in the natural world, collecting valuable data about the health of our planet. Imagine releasing a swarm of robotic bees into a forest. These tiny drones could monitor air quality, track the movement of pollinators, and even identify signs of disease in plants. All of this information could be used to help us better understand and protect our environment. And because they're so small, robotic insects would have minimal impact on the ecosystems they're studying. They could fly through forests, swim through rivers, and even burrow underground without disturbing the delicate balance of nature. When disaster strikes, every second counts. In the aftermath of an earthquake, a hurricane, or any other disaster, search and rescue teams race against time to find survivors. Robotic insects could be a game changer in these situations. Their small size and agility would allow them to navigate through rubble and debris, reaching places that humans can't. Equipped with cameras and sensors, they could quickly locate survivors and relay their location to rescue workers. These tiny robots could also be used to assess the stability of structures, identify hazardous materials, and even deliver emergency supplies to those trapped inside. In the chaos of a disaster, robotic insects could provide a beacon of hope, helping to save lives and reunite families. Section 5. Taking inspiration from nature. Bio-inspired engineering. Building robots that can move like insects is no easy feat. It requires a deep understanding of biology, physics, and engineering. That's why MIT researchers are turning to nature for inspiration, using a process called bio-inspired engineering. By studying the anatomy and movement of insects, engineers are able to design robots that mimic their incredible abilities. For example, by studying the way a dragonfly's wings generate lift, engineers can design robotic wings that are more efficient and maneuverable. This approach has led to the development of robots that can fly like birds, swim like fish, and even climb walls like geckos. By learning from nature, engineers are pushing the boundaries of what's possible in robotics. Section 6. Material Marvels. Building better robots. Building robots as small as insects requires new materials and manufacturing techniques. These tiny robots need to be incredibly precise and efficient, which means every component must be meticulously designed and assembled. The challenge lies in creating parts that are not only small but also functional and durable. Traditional materials like metal and plastic are often too heavy or too rigid for these tiny machines. These materials, while useful in larger robots, simply don't scale down well. They can hinder the movement and functionality of micro-robots, making them less effective in their tasks. That's why researchers are exploring the use of advanced materials like carbon fiber, graphene, and even artificial muscles. These materials offer unique properties that are perfect for the demands of micro-robotics. Carbon fiber is known for its strength and light weight, while graphene offers exceptional electrical conductivity and flexibility. These materials are lightweight, strong, and flexible, making them ideal for building robots that can move and interact with the world in lifelike ways. The flexibility of these materials allows the robots to mimic the movements of real insects, enabling them to navigate complex environments with ease. These new materials are also allowing engineers to create robots that are more durable and resilient. Durability is crucial for robots that need to operate in harsh or unpredictable environments. The resilience of these materials ensures that the robots can continue to function even after sustaining damage. Imagine a robotic insect that can withstand being stepped on or even being caught in a rainstorm. These capabilities open up a wide range of potential applications, from search and rescue missions to environmental monitoring. These are the kinds of advancements that will make robotic insects even more versatile and useful in the real world. As researchers continue to innovate and refine these technologies, we can expect to see robotic insects taking on more complex and critical roles in various fields, revolutionizing the way we interact with our environment. Section 7. Powering up energy sources for tiny titans. One of the biggest challenges in miniature robotics is power. How do you power a robot that's as small as an insect? Traditional batteries are often too big and heavy, and they don't provide enough energy for sustained operation. Researchers are exploring a number of innovative solutions, such as energy harvesting, wireless power transmission, and even micro-fuel cells. Some robots are being designed to harvest energy from their surroundings, like solar power or vibrations. Others might be powered wirelessly, using electromagnetic fields or lasers. Finding efficient and long-lasting power sources is crucial for unlocking the full potential of robotic insects. These tiny robots need to be able to operate for extended periods without needing to be recharged or refueled. Section 8. A swarm of possibilities: the future of robotic insects. The future of robotic insects is full of possibilities. These tiny machines, inspired by the natural world, are set to revolutionize various aspects of our lives. From agriculture to infrastructure, their potential applications are vast and varied. As technology continues to advance, we can expect to see even smaller, more capable, and more intelligent robots. These advancements will allow robotic insects to navigate complex environments with ease, making them invaluable tools in many fields. These robots will be able to perform tasks that are currently unimaginable, transforming industries and improving our lives in countless ways. For instance, in agriculture, they could monitor crop health, apply pesticides precisely, and even assist in pollination. Imagine a future where swarms of robotic insects are used to pollinate crops, inspect infrastructure, and even provide surveillance. These tiny robots could reach places that are difficult or dangerous for humans, ensuring safety and efficiency. These robots could work autonomously or be controlled remotely by humans, acting as extensions of our senses and abilities. This dual capability would make them versatile tools in various scenarios, from search and rescue missions to environmental monitoring. The development of robotic insects is still in its early stages, but the potential is enormous. Researchers are continuously exploring new designs and functionalities, pushing the boundaries of what these tiny machines can achieve. As we continue to unlock the secrets of insect biology and develop new technologies, we can expect to see these tiny machines play an increasingly important role in our world. Their integration into natural and urban environments will mark a significant step forward in the field of robotics, opening up new possibilities for innovation and progress. Section 9. A new frontier in robotics. Robotic insects represent a new frontier in robotics, one that promises to revolutionize our world. By combining the ingenuity of nature with the power of technology, we're creating machines that can go where we can't, do what we can't, and help us understand and protect our planet in ways we never thought possible. The journey into the world of miniature robotics is just beginning. But as with all great explorations, the discoveries we make along the way have the potential to change our world in profound ways. So, the next time you see a fly buzzing around, remember, it might just be the inspiration for the next generation of robots.